Well, good morning, everyone. Welcome to the Wednesday edition of CPT 168. Wednesday morning, what is this, February the 10th? Man, this semester is off and running now. We're into week number 5, and we're missing some folks here this morning. I just noticed that. It looks like 1, 2, 3, 4, 5, 6, 7 students out of our 20 are not with us yet, and hope they show up. So I may be bouncing around here for a few minutes as those folks come into the class, but I wanted to go ahead and get started. Appreciate everybody getting up and coming to class this morning. Know the honeymoon period is over now that we have gotten through test number 1. And I was just looking through our grade book for this section right before class. A couple of observations. There are 3 people in this class that have not or did not post this last week in the forum. And those are easy points. That's one of the reasons we do a forum. Of course, we want you to write and post and discuss things with your classmates. That's the whole point. Try to socialize what we're doing here. And but because that is not an attendance requirement, I guess, folks are not participating as much as I would like. So be sure and get your forum post in each week. Get those points. Some points are better than no points is my motto. And also notice that you might find this interesting. After test 1, out of our 20 students in this class, 4 students have an average over 100. That's really good for a programming class. So either we've made the class really too easy, or we have real smart students that are working hard here. So I'm thinking it's the latter. We have smart students that are working hard. I think the course is positioned pretty much where we intended it to be as far as rigor and so forth. So I hope you guys are enjoying the class. I know I am. And we had the last 2 units have been fairly tough units, long units with a lot of content. And I know some of you guys might have struggled a little bit in units 3 and 4, but those are foundational units. Without those, you'll never understand how to program and how to be successful in Python. So those were important to get through, and we're just going to keep adding on to that. This week, a much shorter unit. Yesterday, we were out of class in just over an hour, so we'll see how we do today. But we're going to talk about ways to test and then debug our programs, testing and debugging. And the testing part's real easy. It's not hard to do at all. And debugging for most part is just common sense. And we'll talk about some strategies, several of them depending on your situation with your program, but several strategies that you might want to use. I think we have a total of 5 different strategies in the chapter, although the writer of the book doesn't really number them like that, but I counted 5 as I've gone through it a couple of times this week already. So I hope that will be helpful for everyone. I'm gonna go ahead and share my screen here and go over what is due this coming week. And let's see, I think you guys can see that now. So you can see that we are into Unit 5, Week 5 up here, how to test and debug a program. And I think every programming class has this type of chapter in it. It is kind of a necessary chapter. And I think it's interesting that they put this chapter right after those 2 foundational kind of basic units that we just did. But it's a good place for the chapter because next week we get into lists and tuples. And if you've done any programming in the past, those are basically arrays. So we're going to start getting more serious here, I guess, or raising the bar, because things are going to continue to build on the foundation that we have set up. So coming up this week, certainly work hard on chapter 5 in the book. It's not a very long chapter, so read it and study it. Download the slides that I put together for you so that you have my notes on that. I try to sprinkle a few things in the slides that are not in the book, may be helpful to you. Also, once again, do that discussion forum topic. We have number 5 this week in 3 labs, and all 3 of these labs are testing and troubleshooting or testing and debugging labs for unit number 5. And then there is a quiz. We don't have any other items to do this week, but we do have a quiz. And you guys have been good on the quizzes. Maybe it's because they are attendance requirements. I don't know, but those get done pretty well. But be sure and work just as hard on the forum topics. A couple of weeks away, we have a test coming up once we get through unit number 7. So next week, unit 6, the week after that, unit 7, and then the test towards the end of the month. So just kind of keep that on your radar. Any questions about what we've got coming up in this class in the next, well, through this week and in the coming weeks? Okay, I don't see anything happening anywhere, so we'll just go ahead and jump into unit number 5. Unit 5 is on how to test and debug a program. The first thing that we've got to do is just understand some definitions. So we'll take a look at the 3 types of error messages or problems that we could have when we write a program. Over the course of the last week, I graded all of your Unit 2 and Unit 3 labs. And I've got 68 students in this course right now that I'm teaching. So I think that was a total of 6 times 68, however much that comes out to. But that's how many labs I graded in the last week. And I saw all 3 of these types of errors: syntax errors, which are basically just misspelling words or maybe a wrong punctuation, something like that. Runtime errors are exceptions that happen after a program has been compiled or as it's being compiled. And then the logic errors. So logic errors are basically errors that happen when you write a program that doesn't do what you are supposed to do or what you intended for it to do. So logic errors are very common, especially when people are learning how to program. So we'll go over some ideas on how to keep up with this and some techniques that will help you improve your testing and debugging. And there's a big difference between testing and debugging. So it's not terribly complicated, but testing, you try to break it, find out where the weaknesses are, and then debugging is when you go in and fix those things that you know are wrong with your program. You will be surprised how many students submitted homework or submitted lab assignments in the last couple of units that were just loaded with bugs. And I don't know whether they thought I wouldn't look or what, but if you submit an assignment that has bugs in it, you're not going to get a very good grade. So not only do you need to do the labs, but you also need to test them and make sure they're right. So like I said, there's going to be 5 different ways we're going to look at this. The first way we're going to look at debugging is one of my favorites. It's the one I use the most. I think most people use it the most. And that is just tracing the execution of your program by inserting strategically located print functions. The idea here is to track the values of your variables. You want to see how your variables are reacting to your coding, and that will uncover a lot of problems very quickly. And so in PHP class, we do that with echo statements. In this class, we do it with print functions. So we'll go over them. The challenge there is to figure out where to put the print functions, and that's not too complicated, but we'll go over how to do that. The second thing we're going to do is talk about top-down coding and testing, which if you do it right, it's going to cut down on the number of error messages you're going to get, and your debugging will be much less. So we talked about it last week when we were talking about creating functions and then running all the functions in the main function. And so it kind of follows along that same train of thought, but it's basically dividing your program into chunks of code, which are functions, testing them though as you go along. One of the things that has been an observation in my vast experience here of a few semesters is that students attack programming like writing an English paper many times. They just start at the top and just write all the way to the end and say, I'm done, I'm finished, it's over with. And that is absolutely the incorrect way to go about writing a program. You need to break it into pieces. You need to test as you go. Test as you go and make sure all of those chunks are working. And so that's really top-down coding and testing. Number two, we're going to do what we talked about all the way back in Unit 1, where we just use the idle shell to test and see what's going on. You can do that with functions too. You just type the function into the shell and then look at the variables and make sure the variables have the values that you anticipate. So that's the second one. The third one we're going to do is we're going to actually, let's see, 1, 2, 3, fourth one we're going to do. Fourth one we're going to do is the idle debugger. Now, this is using a utility that's built into idle. We haven't talked about this, but all IDEs have some type of debugger built into them, or they're not really IDEs. And so the concept here is to kind of ballpark guess where your problem starts. Insert a breakpoint and think about this. This is when you have hundreds of lines of code, a really big program. This is why you would want to put the breakpoint where you think the problem is. And then you open up the debugger, get it started, and go back and run your program, and the debugger will start walking you through line by line of your code. And what is cool about the debugger is you can see your variables change as you go through each line of your code, and that should help you understand where your problems are. Is that different than what we did in the first one with the print functions? It is very similar. It's just using a different tool. Same idea. We got to watch our variables, because without our variables being correct, nothing's going to work. So it's just another way to look at that. And then the fifth thing that we can do here, 1, 2, 3, 4, 5, the fifth thing that we could do is look at the stack viewer, which is also part of the debugging utilities in idle. The stack viewer works differently than the debugger window does, the debug control window, it's called. The stack viewer, and we'll look at that, it concentrates primarily on the stack that you're building in your program through your functions. Okay, so you look at it function by function. You open up each stack and each function in your stack and look at how that code is behaving. Then we wrap up this unit with a review of, we just mentioned again, really, the floating point number problem. We've got to remember that even though the floating point values may calculate correctly to the nth degree, all those decimal points that we have, we need to round those off so that our presentation to the user is much more manageable and looks more precise, even though in reality it might not be quite as precise, but it will look better to the user of your programs. So Unit 5 reviews some of what you've already been experiencing in our class as you've done your labs, and presents some new skills for testing and debugging. Realize that we're going to get much more complicated in our programming. And so being able to test and debug is a skill that we have got to have, or we will not survive. And we certainly want everyone to survive. So the idea behind testing is very simple, and yet a lot of students don't do it very well. And that is to try to figure out how to break your program. You write your program, you know what it's supposed to do, but what happens when you have the drunken town idiot as your user and they're putting all kind of junk responses into your program? What happens? Okay. So you want to emulate that. You want to put in as much invalid data as you can and try to figure out what could happen. If you're asking for input on an integer, some type of number, then put in alpha code, see what happens. I did that in your Unit 3 labs when I was testing them just to see if anybody had worked ahead. I didn't do it on all of them, but a good number of students. I checked it. I just put in some alpha code, and invariably the program would crash. It would just quit running, okay, because it was a data type error. We didn't test for that data type error. We hadn't gotten that far in our data validation, but we will. So that's what we're talking about. Just think of stupid things that could be put into your program, entered into your program, and what would happen. So testing is conceptually very easy. It could be a bit tedious. Now, debugging is where you earn your money, okay? And as I told you when we started the course, my job here is not to be your debugger. My job here is to teach you how to debug, and that's why this is such an important unit in our course. So the whole point behind debugging is finding out where the typo is, or where the logic error is, or where you used the wrong variable or changed case on a variable or something that is causing your program to misbehave. So we need to fix those as we're going along. So let's look at the three types of errors that we could have and see what we can do about them. So, oops, didn't mean to do that yet. The first one of those is the syntax error. And by far, this is the number one error I saw this week in grading your labs. Okay. Syntax errors are exactly what you would think. They are misspelled words. They have the wrong case, something simple. These are the easiest errors to fix because if you have been studying along in the course, you should know what the syntax should be, or be at least really, really close to understanding what the syntax should be. You should understand now that you can go back in the pages of the chapter and look up the syntax and fix your syntax errors. So syntax errors are also called compile time errors because when you hit that F5 key in idle, it's going to pop up and say syntax error. And that's all it's going to say. It may give you some indication with a highlight what line the compiler was in when it ran into the syntax error, but that's not always the case. You have to be doubtful of that, okay? Now, if you are running the program in the Python console, which I tried to do that primarily when I was grading your Unit 3 labs. In other words, just running Python and Windows 10 and not running idle, okay, which is the way your users are going to run your programs, okay? So you hit a syntax error, poof, it disappears from the screen. It crashes. There's no error message on the screen. So once that happens, then I have to open up your code, download your code off of Blackboard, and open up the code in the IDE in idle and see what's what. And I tried to tell you in my notes on your labs, at least what I could uncover as quickly. Sometimes I was more precise than others. It kind of depended on the situation. The second type of error, and I ran into a bunch of these, and John Waters in this class, I don't know if he's in right now because he's got some things on his schedule today. But anyway, the second type of error we can run into are runtime errors. Now, runtime errors are also called exceptions. I changed that question on our tests, by the way. And John was the one that pointed out I needed to have both runtime and exceptions as a type of error. And exceptions are something that we're going to learn how to handle in this class. We can cut this off the, if we learn how to handle exceptions, this will not be a problem once we learn how to code it. And so that's the good news. So syntax, relatively easy to fix. Runtime errors, we're going to anticipate those errors and we're going to handle those. And that's coming up, I think, I got it in my notes here, Unit 8 or 9, somewhere along there. We're going to have a unit on handling exceptions, okay? So exceptions are I don't want to say they're like syntax errors, but they're basically because you didn't program well. You had a programming problem. And so there is something in your program you need to fix. Like you tried to run a function and you didn't have the arguments right or something of that nature. So that is why we get a different type of error message, okay? Then the third thing that happens are logic errors. And these perhaps could be the most difficult to fix because they just don't work. You know, you run your program and you think it looks good. You would be surprised in the last week how many times I ran students' labs. We had math equations and the math was wrong. They didn't check their math. Come on, guys. You know, you think that you're entering the code right. You're doing the math. There's no error message on the screen. Well, if your mathematical calculation, your algorithm is incorrect, the results are going to be wrong. So manually check your math to make sure it is right, because you do not know what parameters I'm going to enter into your program to check your work. So I'm going to put different numbers in. It's not going to be exactly what you were doing, but it's going to be something different. Now, I don't know if it was in this class or another class because I got 4 classes, okay? But I had several students that rather than write computer code were submitting labs to me that were just text files that were output screens. They saw, the anticipated output screens in the chapter. So they just typed it up, put a PY on the end for source code and uploaded it. And needless to say, that was hugely wrong. They got a 0 on the lab. I'm going to run your programs. Do not even think that I'm not going to. And it takes a lot of time. I probably spent 8 or 10 hours in the last week just grading CPT, what is it, CPT 168, I get all my classes mixed up, CPT 168 labs. It takes time, and I'm going to take that time because you're important and your work is important, and I want to make sure I do it right. So we run into those logic errors, I will note it for you. So what causes Python errors? So we actually talked about this in senior project last night if you were in that class. Each programming language has its own personality and its own thing. Indentation is our thing in Python. I think we mentioned that earlier in the course, but Python uses indentation to separate our statements. And so if you don't, and I had a number of students that messed up indentation, and IDE actually tells you there's an indentation problem if you look at the red error message on the screen. So I know students are not testing with the IDE. As a matter of fact, what I think is happening, and if you're doing this, you need to get smart. Students are opening up Notepad++ and writing all the code for the whole lab, like, opening up the starter set of code, going in and fixing it, saving it and submitting it. They never open it up in the IDE. And that is not good. If you're going to use Python to write the code, not Python, but Notepad++, if you're going to use Notepad++ to write your code, which it's not terribly awful, but be sure and open up your source code file, your abc.py file, open up your source code file in the IDE and run it. And so you can see the errors. If you don't do that, you're not ever going to be right. And you would have seen indentation errors. So that one just slaps you in the face. So that is the Python thing, okay? Misspelling words, that happens to everybody. Colons are used in Python at the end of statement lines, at the end of all of our if statements or elses or else ifs or whiles or fors coming up, or tries or excepts. All of those have to have a colon at the end. Yep, Joshua says forgetting that colon will get you. I'm going to tell you something, Joshua. Everybody goes through that. And in this language, it's colons. In other languages, it's semicolons. And those are the little things. But at least you can see it. Be thankful you can see it. And you just have to I don't know, just practice. Practice makes perfect. And eventually you'll realize that you have to have a colon there. So just realize it's all of the statements that we've been talking about, the lines that have key words in them. So ifs, else, whiles, fors, tries, except, all those types of things. This is a partial list here in this slide. And also remember, if you have one quotation mark, one parens, okay, one curly brace, whatever, you got to have the other one. They come in pairs. You will never run them singularly. That's a hard word to say. So make sure brackets is the other one. You have the left and the right, the opening and the closing. So when you write a line of code, look at it and say, did I do all of the parentheses or the quotation marks correctly? We had some lines of code in Unit 3 where we had 3 sets of parentheses, boom, 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 because we had embedded functions. So we had all these parentheses in there, and sometimes you just have to count, okay? So just count them. Improper indentation probably, well, you know, thinking about indentation, I believe out of the 68 students I graded, and I must have graded, you know, close to 300, 350 labs, I only saw one serious indentation problem. One guy did everything on the left side, left margin. That's not going to work. So I know he never opened up the IDE. He never tried to fix the problems. So remember that once you start working on a variable, you can't change the name of the variable in process. So misspelling or incorrectly capitalizing a variable or function name is going to get you every time. That is a simple syntax error to fix. Very simple. It just takes a second. So just run the IDE. It will jump out at you. It will just tell you that this variable does not exist, and it's probably because you changed case. I saw that at least a half a dozen times grading labs. Using a keyword as a variable or function name, yeah, you can't use those. Once you create a function name, it has to be a function. All those keywords that are hard coded into Python, we can't use those as variable names. All that basic stuff we talked about in the previous units. Data type is always going to be our curse. So some students are struggling with data type more than others. One little hint that I will give you, if you know that you need for the data type to be a string and you're not sure whether it's a string or not, run it through the string function anyway. If you run a string through a string function, I don't think you're going to get an error message. It's kind of like double checking. So, you know, if you're unsure, run it through the string function and see if that changes your problem, if it changes your situation. That will tell you whether you have a string or not. And one same thing in reverse. If you need for it to be an integer or a float, then change the data type on the variable and see what happens. You don't have to spend hours guessing. Just change it and see. I had one fellow in the course who's probably sent me a half a dozen emails fretting, worrying about data type, and it's something to be concerned about. But just remember, we have functions that we can use. Just go ahead and change it, okay? All right. So a note here about the float type problem again. And this is kind of a reinforcement slide. We've already done this before. This is review. But there are many, many times that we're going to be dealing with decimal numbers. Those are float numbers, okay? Decimal numbers. When we're dealing with money, we're going to be using a float value. If we're dealing with tenths of gallons or tenths of degrees, those are float values. Anything that has a decimal point, okay? It's a necessary thing in math. Just remember, we do have this situation in Python where Python tries to be really, 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 really exact on the float point and creates a long list of digits here, which is more than we need. So that is why we need to run the round function. The round function, the name of the variable that we want to round, and the number of digits we want to round it to. So very simple function. There are still students in the course that are not using the round function, and we want to make sure you do that. Now, coming up in Unit 9, which seems a long time away, it's a month away in the future, we're going to get to a standard module called the decimal module. Okay. At that point, I will say something to you like, okay, now we don't have to use the round function. We can import this decimal module and use it in our code, but let's not get ahead of ourselves. Right now, we can use the round function to solve the problem, and we'll be much better programmers in a month. We'll have a lot more experience, and we can use that standard decimal module to solve that problem at that point. All right, so let's talk about test plans for a minute. This is lab 5-1, by the way. So if you're going to be a tester, okay, you need to have a test plan. Now, right now, you guys don't have a staff. You don't have any subordinates to do the dirty work for you. So you're going to have to be your own tester. So the thing that we have to deal with now is we have to write a test plan. And that is part of your assignment in lab 5-1 this week. Now, a test plan has two parts, okay? The first phase, you test the program with valid data. This is what is supposed to happen, valid data. And then the second phase is invalid data. So if you enter this invalid data, this is what happens, okay? Now, depending on your program, you may not at this point be data validating to the point that all of your phase 2 is going to be correct. But let's at least test it, okay? Let's start getting in the mindset of a test plan. Now, the textbook in Lab 5-1 says that you can write this out in longhand or do it in an Excel spreadsheet. I'm going to tell you, for simplicity's sake, while we are doing labs the way we are and submitting them to Blackboard, please use a spreadsheet. Don't write this out in longhand. And this does not have to be a fantastically color-coded, super-duper document. It really just needs to be a two-part spreadsheet, valid data in phase 1, invalid data in phase 2, 2 columns in each phase. Here's the test data, here's the results. Here's the test data, here's the results. And students say, well, do you have a sample test plan for me to look at? I want you to think about this. I want you to come up with your own design, okay? This kind of helps me get in your head a little bit. So you will need to create a test plan, and you need to break it into 2 parts: valid data, invalid data. Each part has 2 columns, input and output, okay? So it should include all varieties of entries, okay? Remember, the first part's going to be the guy that reads instructions and does exactly what you want. That's going to be the perfect user. That's going to be your A student, okay? And then the second part's going to be the guy that's drank a 6-pack of beer, and he's not the brightest bulb in the pack, and he just puts junk in your prompts. After your prompts in your program, what happens? You know, is it going to blow the program up? Is it going to deliver an error message? What's going to happen? So the end result of a test plan should be there are no surprises. We have tested. This is all known. These are known quantities. So phase 1, put in valid data like we see here in our miles per gallon program. We're just inputting valid integers in the return for the prompts, okay? And here's some invalid data that could happen, okay? And I did this when I was grading your Unit 3 labs. Notice the negative number for yearly interest rate. That would be a really bad year if you were given interest rate back. The low number on interest rate would have to be 0. You're earning nothing. So anyway, in this program, -12 is certainly invalid data. What happened? So that would be the second part. So list the valid entries and then the correct results, what would happen. Okay, that's the first part. Maybe skip a couple of lines and then have the invalid entries, and you'll have a column of what you input and what the output is. Okay, so in lab 5-1, you're going to create this test plan. It's either going to be a .xls or .xlsx file, Excel file. It's going to contain the test data and the results that you got. And this should be for real stuff. This should be the data that you tested, and these are the results that you got. Okay, and you're going to submit that test plan spreadsheet as well as the test scores PY to Blackboard, and I will grade those. Now, most of the grading on lab 5-1 is going to be that test plan spreadsheet. So the reason I'm making a big deal out of this is different than what we've done for the last 3 units. I got you kind of used to submitting the PY source code files. Now we're adding something to it. I am finding out that at least 10 to 15% of our students in this class are not reading the submission instructions in Blackboard. This came out of the submission instructions in Blackboard. People are doing the lab and then sending me, snippets like we did in Unit 1. And we haven't done a snippet or screenshot since the second lab of the course. And how many labs have we done up to this point? So I'm still getting screenshots, and that's got to stop. We got to move forward and do this the right way. And as professional technicians, we have got to read instructions and follow instructions. And that's part of my job as your instructor, to coach you to the point where you're doing that. So common testing problems are, hey, I'm just too busy. It looks right to me. Here it is. There's a lot of reasons for not testing well. And it's a common problem with students that they don't test well. And I don't really understand it because it's not complicated. So not testing is a wide enough range of entries. Just testing known good is not going to be enough testing. You have to also test known bad, okay? Things that could make it break. Not knowing what the results of each set of entries should be and assuming that the answers are correct because they look correct, that's back to my math problem. And I think math problems fit under logic because you're not doing it. It looks right, but the answer's wrong. So you should fix that. You better manually check. You're just in too much of a hurry. Hopefully you're not lazy, but that kind of creeps in there. Some folks are lazy. All right, so let's go through the 5 ways now that we can debug. Now that we have gotten testing out of the way, we should, at this point, know whether our program works or not. We should have uncovered issues that we need to fix. And so let's go through 5 different things we could do for testing. When I learned to program, nobody told me this. I had to figure out how to debug on my own. I think that having somebody help you understand this is very important. I do think that debugging is an art form. You have to have patience. You have to be a problem solver. And that is what we get paid for, folks. That is what we get paid for. We make our money for fixing problems. If there are no problems, there are no opportunities to make money. It's just that simple. Logan, I'm sorry, I missed your comment a few minutes ago. Is there a preferred amount of entries into the test Excel sheet? That is a really good question, Logan. And the answer is enough entries to prove your point. Okay. So this is not a numbers game. Now, I can't say that 6 is the magic number or 3 is the magic number. The magic number is how many entries does it take to do an adequate job of testing? Every program's different. So that answer is going to be different on every program. So we're working on simple programs right now, and that's okay. We're just learning. We're getting started. So you're not going to have a ton of entries. I would think off the top of my head, 5 or 6 valid data and 5 or 6 or maybe 10 invalid datas, invalid because that can be anything. Okay. So there may be more entries there, but that's a good question. I appreciate you asking that. Sorry, I jumped over that. All right. So 5 things we're going to do. The first thing we want to do is just trace the execution of the program. Now, actually, all 5 of these, if you think about it, trace the execution of the program. We want to go from the top to the bottom. We want to go line by line. And since we're breaking our programs into functions, we actually have to go function by function by function. Okay. And so we have to trace that execution. There are several different ways to do it. To me, one of the easiest ways to do it is to put a print function strategically located for testing purposes and debugging purposes in key places in our functions. They actually should be in your functions if you want to know the truth, the way we're programming here, okay? Because you're going to have some print statements at the end in the main function, right? But what about inside the functions when you're testing? Now, you're not going to leave these print functions in there. These are temporary. They're just in your program while you are debugging. Once you've corrected your problems, you can either delete the print functions or you can put a pound sign in front of those lines and just remark them out so that they can be there for future reference. If you go back and look at any of the work that I've done, I think you're going to find echo statements or print functions buried in there that have been remarked out because I was trying to figure out what was going wrong. And that is just as common as dirt. So everybody's going to do something. And I think this is a good way to trace that execution of the program by embedding those print functions. Okay. So here's an example of what I'm talking about. There are 2 print functions here. This first one is just a heading. Okay. This really does not do anything for us here, but notice we're in a function that we have written. We're writing the calculate future value function. And we just put this in here for a temporary note. This is good for code review, by the way. And then down here at the end of our for loop, inside the function, right before we return future value, notice this is kind of strategic because we're going to return this to the calling function here. But right before that, we write a print function. And this is, you can have any kind of style, but at the end of the day, this print function needs to have that value right there. Now, in this case, it has to have future value. That is what we're looking at. It is kind of nice that we also are going to include I, which is our iterator here in the for loop. So we can see loop 1, loop 2, loop 3, loop 4. So we can see how the math is working. Now, think about this. When you're compounding interest in a calculation, you want to see that it's actually happening. So this is a test. Now, once you put this, or right before you put this program into production at your company, you want to take this line out. You might want to take this line out too, and just have the code there because you have the main function that's going to do all the fancy stuff. So if you just run this function by itself, execute that function, it would look something like this. You have your input statements up at the top, input functions. So input the monthly investment and how many or what your yearly interest rate is. That always throws me because it doesn't have a percent sign there. And then the number of years that you're going to calculate for. So how much per month, what's the interest rate, annual interest rate, and how many years. This we were doing in Unit 3, okay? So you can see the compounding effect. Now, these are floats. Yeah, buddy. So we learned something here. We see, okay, I may need to round that. That's something we got to think about. If I'm going to print out all these iterations, or all I'm going to do is print out the future value, then I just put the round function there. So you learn a lot by analyzing this. Got your while loop here. So you can see whether your while loop's going to work. That's good too. All right, Joshua just posted something. Let's see here. I used and in a conditional statement when I should have used or. That's like 180 degrees off. So yeah, that could be a problem. Took me a while to figure out why I wasn't getting the expected results. Logic error. Okay, this might have helped me figure it out quicker. Well, I guess I apologize because we didn't tell you till now, but you're right. This would have helped. Especially if you had, well, I think what you're saying is you would have put a print function pretty close to after you had your conditional statement in your code, and you would have seen the condition of your variables at that point, the value of those variables, and you would have figured it out. So I agree with you. All right. So number 2 on our list of 5 things, top-down coding, simplify your debugging. We actually just did that. We just looked at one function and we got that one function doing what we wanted. And so that is kind of what top-down coding is all about. If we go back in our time capsule to last week where we were writing our own functions, and in last week's class, we talked about the logical order of our functions in our program. So remember that part. So we have logical order of our functions. We'll end up with our main function at the bottom. So top-down coding just means do a function, go ahead and put it in the main function so you can execute the main function. So when you test from top down, you're going to test that first function and the main function, see if that part works. Then you'll add your second function, maybe your third function, put those calls down in your main function, run the main function, run the whole thing again, and see if there are any errors. Once again, code and test, code and test, code and test, code and test. We're just breaking it into chunks, and we're testing as we go. So the first testing phase would be like this. You would code 1 or 2 functions needed, then put those in the main function, the calling statements, okay? Then run the main function, see if there's any problems. Bing, good, worked, check mark. Now we move on. So in phase 2, you code another function or 2, depends on your program. Put those calling statements in the main function and run the whole program again. It should be clean if you're lucky, or you're going to see that you might have a problem in the third or fourth function that you got to fix. So you get those, okay? And then at the end, you should just have a little bit of work to do to finish out your program, finish out the main function. You've done all your testing, you've done your debugging, and now you can do some industrial testing. This is where you would execute your test plan once you have all your functions written and you have your main function doing what it's supposed to do. All of your import statements are working. Everything's working the way it's supposed to. And you have done it from top down. That's a simple way to debug. It's just bite off one mouthful at a time. That, oh, how do you eat an elephant joke? One mouthful at a time. But start at the top and work to the bottom and include the main function in it. So here's another way to look at it. Remember last week we talked about the hierarchy chart of our functions? So if we work top down and we have our hierarchy chart, main is at the top. So we have to include main in our top down testing, okay? Because we included that in the design of our program or project. And so we would write possibly the calculate future value function, add the calling statement to our main function, test that much work, see if that much work works. Then run the get float function, do the same thing, put it in the main function, test that, and then add the get integer function. And so if you were to write this out, test phase 1, the main function and the calculate function. Okay. Test phase 2, add data validation for the float entries and test that, see if it works. Then test 3, add data validation for the integer entries. Now we've done all 3 of those functions there, and we've added them to the main function, and we test. Then test 4, whatever we have to add to the main function to finish out our program to make it look nice. That should be easy. And then we're in good shape. So that is a good way to do it, the top down. Third idea, okay, and all of these are not, each one of these is not exclusive. You can combine these, okay. You can use a little of this and a little of that to get the job done, okay. So you could do top down, for example, and you think you got that working right, but go ahead and do this one too. The third one here, run your PY source code one more time in the shell and press that F5 key on your IDE and see if there are any error messages. The IDE is your friend. The more you use it, the better you're going to get at it, okay? So however you're writing your code, you need to test in the IDE because that is what's going to tell you where your problems are, okay? So don't forget to use it, okay? So just some screenshots of testing these functions inside the IDE, okay? So in this first line here, we're entering our call here for the get float function, okay? We're going to calculate for new value using the get float function, and we enter the numbers that we need here for the get float function to work, okay? And so we enter the numbers, okay, and we see what happens. And there's some data validation here. That's good. Data validation works. And then we actually put in a valid number here, 1,000, and we call up the variable that we're creating here to see what its value is. We see we're good. That's exactly right. Doing the same thing here again, okay, same process. So you see we're just using the interactive shell here, making it test for us. That's another way to do it. You can actually run the functions in the shell. I don't know if you've tried this or not. You might be writing your code in like I said, Notepad++, but you can also run your functions just like this. You can run your functions inside the Python IDE shell and see what happens. Another example here, running the convert temp for Fahrenheit and the convert temp for Celsius from our temperatures program. This is kind of a rehash of what we had a couple of weeks ago, okay? So you see that works. Testing the import part of this, you know, remember that whole thing about importing modules, import temperature as T in that specified namespace, and test that. Make sure it all works the way you think it should. So that's number 3. Very simple. Probably most of you have already been doing that, okay? Now let's get to number 4, the idle debugger. We have not talked about this before. And just remember that each IDE probably has a different way of handling debugger. For example, if you're using PyCharm instead of idle, this is not going to help you so much. You're going to have to learn the PyCharm debugger. But the idea behind a good debugger is you can step through your program line by line. And let me emphasize that the debugger in idle really is more helpful in larger programs than we're dealing with now. Now, we're in our labs here in Unit 5, you're going to use the debugger, and that's good for practice, for learning, okay? But in the real world, this pays back huge dividends when you have hundreds of lines of code and you're trying to fix something. If you're working in a programming shop for a company somewhere and you are doing a code review for one of your colleagues, they've been working on a project and they say, hey, I want you to look at this and help me figure out why it's not working. Now we got to have a debugger. Okay, now we need to have one. So the first step in using the idle debugger is to set up breakpoints. Okay. Now imagine your programs now are 200 or 300, 400, 500, 600 lines long, and you don't want to spend an hour and a half going line by line by line. Okay. You've run the program, you've looked at what the interactive shell tells you, you have some idea of where your problem exists. So you enter a breakpoint inside the idle editor, okay? Inside the interactive editor. You just right click on a line of code, a drop down menu will come up there, and you click on select or set breakpoint, and it's just going to highlight that line, okay? And it's going to set a breakpoint. Now, here's the gotcha. You want that breakpoint to be above where you think the problem is, because that a breakpoint is the starting point for the debugger to start working, okay? You can have a second breakpoint, and that will be second breakpoint, and that'll be where the debugger stops, okay? But you definitely got to have one to start. If you have just one, it'll debug all the way to the end of the program, okay? So it has to be above. If it is the line or below the line where the problem is, it's not going to help you, okay? So that is why you want to run the code in the idle interactive editor, okay, in the shell, and see where the problem is. Get as much information as you can. And if you have a runtime error, you're going to get a line number in the output, of the error. Okay, so once you set that breakpoint, then you can work your way down as you go through each line, okay? Now, the book makes a point. Hopefully you already figured this out. You don't want your breakpoint to be on a non-executing line of code, like a comment. Any documentation, we don't care about that. So you just want it to be above where the problem is, but it needs to be an executing line of code. And the reason for this is real simple. Idle is going to be executing code going through your program, and it sees that breakpoint during an execution, and it stops, okay? Now, if that line were a comment, it would just ignore it. So the breakpoint would never be seen. That's the problem. So how do you start the debugger? You open up idle, you import your PY file, and then you go up to the menu at the top of the screen, go to the debug drop-down menu and click on debugger. That should open up a debug control window. Now, another little gotcha here, a procedural thing you need to think about. You need to check the source box, which is not checked by default. We're going to talk about that when I have the screen up here. But there's a little bit of setup you got to do inside the debugger. So the breakpoint needs to be above. You open up the debugger, the debug control windows there. You want to check source box, okay? So this is what it looks like when you set a breakpoint. It highlights, okay, nice and pretty. So you know where the breakpoint is. And you guys are going to submit a lab to me. And I think it's lab 5.3, if I remember right. And there are going to be breakpoints in it. Now, I'm going back to reading the lab on Monday, and today's Wednesday. That's like a month ago. But I think the lab says to remove the breakpoints. I do not have a problem with you leaving those breakpoints in there if you want to. I want to see that you've done the work. Okay. So if you leave them in there, that's okay. So that's what it would look like. It should be a yellow line across there. So at this point, once you have the debugger running, breakpoint set, debugger running, then you're going to switch back to the editor and run the program. The program's going to hit that breakpoint, and then it's going to open up the debug control window a second time. Okay. So we go to the editor, we set the debugger, we go back to the editor, we run the program, and then the debugger will open up on the breakpoint. So at that point, you'll want to click the go button in the debugger window, which will start stepping through the lines of code. So this is going to make more sense now. This is the debug control window. That's the first thing, debug control window. And so you see it says debug control there. There's that source box. So that means source code. You'll see that stack and locals is probably already checked. This is an old screenshot. I have not run the newest version on this. I need to do that. You guys are going to do it probably before I will, but so we want to check the stack. We want to check the local variables. If you want to check global variables, you would check this one. Okay. You got 5 buttons here. Go starts the debugger. Not a whole lot's going to happen there. The screen will change just a little bit. And then you are going to step through each line of code. Okay. So it shows you where you are in the program. But this is the thing that's interesting about the debugger. It's going to list the variables that are in memory here from your program, and it'll show you those variables as they change as you go line by line through your code. That's the big deal. You want to watch those variables. You can also see your code here, and maybe you'll see your typo or whatever the problem is right along here, but not necessarily. That may be the case, may not. So a word to the wise here. This is a suggestion. You don't have to do this, but you're going to have 3 different windows open at this point. You're going to have the interactive shell open. You're going to have your program running, and you're going to have the debugger open. Okay. So you're going to have 3 different windows open on the screen. So use your real estate wisely so you can watch all 3 at the same time. So I think I've already covered this. You run the debugger, it hits the breakpoint, it stops execution at that point and waits for you to start the debugger control window, and then you step through, okay? And so as you step through, you hit the step button and step through. Now notice the locals are changing. And at the beginning, it's going to be just globals, but now we're going to see some locals down here. Okay, that's a good thing. These are the 5 buttons. We said go to run the program until the next breakpoint or the end of the program, whichever comes first. So that starts the debugger. Step through the code, 1 statement at a time, including statements in called functions. Over, haven't mentioned this one, over and out. We haven't done these 2. Over is step through the code 1 step at a time, skipping over called functions, but still executing them. I do not have a real good example of why we would do that, but it is possible. Out, finish executing the current function and return to the calling function. So if you wanted to step through the current function and then go back out, you could, rather than go to the next line. And then quit, which is easy. That ends the program. So that's no big deal. All right. So that is a way to do this. Personally, I would check globals too in those 4 little check boxes because I want to see everything that's going on. But you make up your mind whether you want to do that or not. You definitely got to check the local variables, but globals might be a good idea too. Step through the program. It's a good way to understand what is happening and when it happens. And especially here in the early going, this is a good way for you guys to understand the logic as the code is digested. And there's one more. This is the fifth thing, the fifth suggestion, 5 of these puppies. And this happens when you have a runtime error. You get an exception, okay? So when an exception occurs, it's helpful to view the stack. You want to see the function where the exception occurred. That's what we're talking about, viewing the stack. The stack is a list of the functions that you have in your program, and it has them in reverse sequence from the way they're called. So the most recently called function is the focus of the stack. And then above that would be the functions that were called earlier if you wanted to work backwards. And so after an exception occurs, you can open up the stack viewer by going back to that debug menu at the top of the screen and now select the stack viewer instead of the debuggers in the same list as we were looking at a minute ago. So and I know lots of you guys got exceptions because I saw your code in Unit 3. So when you have an exception, click on debug and click on stack viewer, and you can go through the lines of the function that is the problem in your program and hopefully figure out what you did wrong. So you'll see it has a list of functions. So you want to go to the function that you think the problem is in, and it could be the one on the bottom, which would be the most current, or the one above it, whatever. And then press the little plus sign to expand it. You've done that a million times. So it's one of those trees of lines of code. And so you want to click on the plus sign to open up the function so you can go through the lines. Okay. So this is what it would look like. And so the most recent function that was run is this one. Okay. And so there was a plus sign there. We click on it and it makes it a minus sign. And now it opens up all the variables in that function. I see what's going on here, and I understand the whole reason for the stack viewer. I don't know that you're going to get a whole bunch of benefit out of this right now. I want you to learn how to use it. That's why we do it in Unit 5. But this may not be something you need a whole lot. Okay, I'm just being honest with you. You may need this more as you get in more complicated programs. If we had a Python 2 course, you would be using this a lot. You may want to use this a month from now. So just remember that it exists. This just gives you a simple way to look at your program as a group of functions in reverse order, and you can click on them and see what the variables are doing inside those functions. It may be helpful. It's a good way to investigate what's going on in your program when it runs. So as I said, I'm going to give you back some of that time we ran over in Unit 2 and Unit 3. So here's the terms list for Unit 5, okay? It's much shorter, okay? We're starting to build our vocabulary. And so all of the new words that we just talked about in Unit 5 are listed here. You should understand all the definitions for these. Work on your flashcards. You should keep building a nice stack of flashcards, maybe separate them by units so you know which unit's what, and learn all of these terms. The summary at the end of the chapter will help you see the terms in context, okay, in the context of how they were discussed in the chapter. Or you can go back in the chapter and do the same thing, okay? So are there any questions that I can help you with that we haven't already fielded here for unit number 5? Things to do this week. You need to read and study chapter 5. It's a little shorter chapter, so you'll get through it pretty quick. Download these slides I worked on. There have been 3 versions of these slides this week. I don't anticipate changing them again. So this should be the current set that are posted on my website. Complete and submit that topic 5. You guys that haven't been doing the forum, get back on board. You need those points, so start posting in the forum. And then you've got 3 labs. and be sure and read the instructions in Blackboard that detail for you exactly what you need to submit to me, okay? And that will be helpful. Sorry about that. Almost made it through class without a phone call. And then be sure and do your quiz at the end. That's your attendance assignment. And you guys have been doing pretty good on that. I don't need to harp on the quiz too much. I think you've got that. So let's see. Logan, is that a new question? Let me look. If you put the breakpoint on a line with an inline comment, would it still skip it? No, I don't think it would. It would see the execution first, the executable line, part of the line first. I hadn't thought about that one. That's a good question. What I'm concerned about is the line where the pound sign is all the way on the left. That's going to be automatically excluded, okay? So if it sees a keyword, it's going to process that line, okay? If it doesn't, let me know, but that's what I would expect. Anybody else got a question?
I have a question about Unit 4, if you wouldn't mind staying on a little bit.
Okay.
I want to keep everybody.
Well, they can drop off if they want to. Go ahead.
Okay. It was from the Unit 4 quiz.
Okay.
And I know the numbers are different for everybody, so it's one about, it gives the code, and then let's see, it's code example 4-2.
Let me write that down because you're giving me way too much credit. I don't remember.
Oh, I know. Yeah, I know. I can email it to you if that's
Well, that's fine. Go ahead with your question. We already started the conversation. It's 4-1, right?
4-2.
4-2. Okay.
Yeah, code example 4-2.
Okay.
It basically, the question is, if you add the following code to the end of the main method, what does it print to the console?
Okay.
And it gives a print statement.
Yep.
The answer was nothing. It causes an error. But I copy and pasted everything into the idle, and it did not produce an error. So I'm wondering if I just misread the question, or
No, you probably uncovered something. Did anybody else in the class see that? Back to full disclosure, those questions that are in the quizzes came from the publisher. I didn't write those, so don't throw any rotten tomatoes at me.
no, I understand.
But
that.
I didn't do all of them either, okay? So that's on me. I didn't test them all. And what's interesting, just to show you the progress of things, nobody last semester found any problems with any of those questions. And you guys are uncovering them, so y'all are a lot smarter than the guys last semester, I guess. But I'm gonna have to go back and look at that one. So do this for me. Anybody in class, if you'll do this for me, because I just think it's interesting. I'll figure it out. I know how to program at least this much, okay? But send me an email, let me know what you think the problem is, what it should be. So Joshua, you can do that. You can just send me a simple little email and say, I think it ought to be XYZ, and
Okay,
see
sure.
if you're right. But probably it's a typo in the book. I've found several of them, and it's always on the answer that they mark as correct. There's just something that's not quite right. So.
Right. I should have sent you an email first. I just start second guessing myself and thinking I must have just misread it or something.
My goal is not to trick anybody. My goal is not to waste your time on trivial stuff that's not going to help. So you have my permission to send me an email anytime something doesn't look right. And this is only the second semester for this whole course in this book, and we're figuring things out. I mean, my notes are completely different. The lectures are completely different than they were last semester. And, in the hallways there at school, we always say it takes about 3 semesters of teaching a class before we get it right. And that's true. And we have to debug it. And there's only so many things we're going to catch by ourselves. So I appreciate the input on that. And David says he noticed the same thing. So any guidance or help that you can provide me on problems like that, I will certainly fix them and replenish your points for that. Okay.
Okay, great. Thank you very much.
Yeah, we all have good days and bad days, right? Anyway, any other questions? That was a good one. You guys come up with great questions. I have a question about the labs. On a couple of mine, you left a comment to work on column alignment. What do you mean by that? Okay, that's David Dunn. David, it's pretty simple. I don't want you to develop a bad habit, okay? So not only as programmers are we responsible for writing a program that works, it also has to be user-friendly and it has to look professional, okay? So if I said column alignment, work on column alignment, and I said that a lot. I said that a ton last week. I want things to line up just like they would line up in a spreadsheet, okay? I want the columns to be nice and straight. Maybe I should take, I should do a comparison, you know, a before and after, something like that, and put it into class so everybody knows what I'm talking about. That would be a something I can do to help. But some students would submit something and no two responses, no two print functions were under any of them. They were all over the place, like a zigzag. And some people would just have one off, you know. Now, some people would have a group here and then a group over here. And if there was a logical separation between those values, then that's okay. But just kind of think, the easiest way I can tell you, just think like you're writing a spreadsheet without the help of Excel. So you want the columns to line up. When we get decimal points in our numbers, that's going to present another challenge for us. We want our decimal points to line up. So just it's all about making a professional presentation. And my thinking is I want to nip this problem in the bud. I just want to go ahead and put that out on the table. And I'll be honest with you, that was the only problem you had in the lab. I counted off 5 points to get your attention, okay? And if it continues to be a problem, that 5 points will go to 10 points, okay? But now that I got your attention and we've talked about this, hopefully it'll go away. We won't have that problem. Yeah, when you run the program and you get output, yeah. What does the end product look like? What does the innocent user of your program see? Okay. When it asks for input, you process it, you have print functions, you have output. I want that output all lined up. I will try to do a good and a bad comparison for you. It'll take me a few minutes to put that together, but it'll either be this afternoon or tomorrow. I'll get something posted for you. I'll try to put something in the class because you brought that up. That's a good point. I should give you an example on that. I don't want anybody to be confused. And that is a prevalent problem because students think it's all about the answer. It's also all about how you show the answer. Okay. We want to show it in a professional way. Good question. Just about making it look good. Very cosmetic. Okay. It doesn't affect the calculation or the functioning of the code at all or how the code works. Any other questions? Okay, guys. Well, you guys have a great week. Stay safe. And I will see you next Wednesday morning and we'll tackle, what is it, Unit 6 next week. Have a good week, everybody.